Yeah, what's the matter, Trevor? You can't do this problem. How long you been here? How long? That explains a lot. So let's have a look at this problem that Trevor's stumped by. So it's a little bit more complex than some of them we've been looking at in the past, but let's make a start. So first, we look at the reactants. We've got lead nitrate. Now lead is Pb, because it comes from the Latin for lead, which is plumbum, which is a brilliant name. So let's have a look at that. It's got a 2 here in brackets, that Roman numeral 2, which shows that the ion of lead here that we're using is 2 plus. We know it's 2 because it says it's 2. We know it's plus because it's a metal. It's not going to be gaining any electrons because it's not a non-metal. Metal ions are positive. Then we look at nitrate. Nitrate is NO3, as you'll check on the polyatomic ions sheet, because you don't believe anything I do, or you shouldn't. Now we've got an issue here. Now we've got lead with 2 pluses, and we've got nitrate with 1 minus. There's an imbalance. It's too many pluses. So we need more minuses. So we put a 2 there, and that's ridiculous, because that looks like we've got 32 oxygens and 1 nitrogen. Absurd. We want 2 nitrates. So we put parentheses around the whole nitrate, including the charge. And then we put our little subscript 2 there. So now we've got 2 nitrate ions. So we've got 2 negatives. And that balances out the 2 positives perfectly. The next one we've got potassium iodide. Potassium is K, because it comes from Kalium, which is German and quite possibly Latin, I'm not sure. And it's in group 1. If it's in group 1, it loses its 1 valence electron, and its ion has a single positive charge. Iodine, well, let's go down here. FCl, then it goes Br, then iodine. It's not in the first 20 elements, but you know it's in group 7. So if it's in group 7, just like fluorine, it's going to gain 1 electron when it forms an ion. And there it is. We don't need to balance that. That's a plus, that's a minus. They balance out to a net charge of 0. So now let's have a look at what they're going to do when they do a chemical reaction. I'll just emphasise that single negative charge. Excuse me, Trevor, you're not doing anything there. Let's move out of the way, please. Yeah. All right, now we put our little arrow there to show that we're going to do products. On this side, reactants. That side, products. So let's have a look what we get when we mix these 2 substances. Here's lead, there's the positive ion. Now we take the negative ion of the other one. It's called a double displacement reaction, because that's going to displace that, and that's going to displace that. And so we get lead iodide. 2 pluses and 1 minus. Once again, we need 2 of the negative ions. So, except we don't need those parentheses because there's only 1 atom. There's no possible confusion. Let's get rid of those parentheses. They are unnecessary. And let's work out the other product. And now we've got K. We haven't used that one yet. K is the positive ion. The 1 remaining negative ion is nitrate, NO3 minus. Now, all of our substances are balanced. If our substances are balanced, we can't put any more subscripts there, because subscripts are just for the formula. What we're going to do now is balance the equation. And the only way we can balance an equation once the formulae are done is to add big numbers in front of the formulae. So let's have a look how we're going to do that. So here's Pb2 plus, NO3 minus 2. We've got 2 nitrates. But here, we've only got 1 nitrate. Oh, I could add another 2 here, but no, that would be wrong. If I put 2 nitrates there, that'd be 2 minus, and that'd be 2 minus, and there's only 1 plus there. The only way we can get 2 nitrates is put a big 2 in the front. But now we've got 2 potassium ions. So here, we can't just do that. because that would be unbalanced. Oh no. We have to put a 2 in front of there. Now let's see if we're balanced. On the left-hand side of the equation, on the reactant side, we've got 1 lead 2 plus. On the products, 1 lead 2 plus. On the reactant side, the left-hand side, we've got 2 nitrates. On the right-hand side, 2 nitrates. On the left-hand side, 2 potassiums, 2. On the left-hand side, 2 iodides. On the right-hand side, 2 iodides. It's balanced. One more thing we've got to do. We've got to answer that question. We haven't done that yet. Let's work out the solubilities. So, lead nitrate. All nitrates are soluble. We put an aqueous after that. Ooh, it's getting crowded up. Potassium iodide. All group 1 ionic compounds are soluble. This one's soluble. That's also aqueous. Well, if you want to consider it, if they weren't aqueous, if they weren't soluble, we wouldn't be able to mix them and get a reaction. So, of course, the reactants are soluble. Let's have a look at this. Lead iodide. Iodide is a group 7. All group 7 compounds that are ionic are soluble, except AgCl, AgBr, AgI, PbCl2, PbBr2, PbI2. That's this. That's solid. It's insoluble. That's our yellow stuff. And the final bit of the puzzle, all group 1 ionic compounds, soluble. All nitrates, soluble. So it's soluble. It's aqueous. So there's the answer to our puzzle. We look for the insoluble product, lead iodide. It's the yellow stuff. Peace and happiness, brothers and sisters.